Alright, it's recording. Okay, the fifth video for the APR standard, arithmetic with polynomials and rational equations and functions. This is the review series for videos for the spring semester 2019, second semester Math 3 final review. Remember, like I say on every one of these videos, this is not an all-inclusive video series or the review document that I made to help you guys study. Make sure you are responsible for studying everything we've learned throughout the entire year. Okay, going back to here, just to add or subtract an expression, not an equation, we have to get these over a common denominator. Can you guys tell me what the common denominator is of 6, 4x, and x? How about 12x, right? So if the common denominator is 12x, let's write that down here like this. We do that so we can see what I have to multiply times each term. So what did I multiply times 6 to get to 12x? Yeah, so you multiply it by 2x. I'm just going to write that like that. And this numerator becomes 6x. Does that make sense to everybody? So the key step in adding and subtracting expressions that have unlike denominators is finding the least common denominator and then writing it down here, and then identifying separately for each term what you have to multiply to get over the common denominator. Any questions on that? Okay, let's finish this up. What did I multiply times 4x to get to 12x? Just 3. So I'm going to 3 times that is 21. And what did I multiply here? Multiply times 12. So that's plus 144. So we got 6x is going to be one term. And what's negative 21 plus 144? Is that 123? How's that? Could you factor out a 3 out of those terms? I think so, but we won't do that. We'll just leave it like that. Okay? And let's go on to the big mamma jamma, divide. You have to do all kinds of greatest common factoring and magic X factoring and see what cancels. So everybody track with me as we look through this. We're going to kind of do 2 steps in one here just to save space. Look at the top left. Do you guys see an X as the GCF? Everybody sees the x, so factor out the x, and then we've got a trinomial. Well, it multiplies to 12, but adds up to 1. Isn't it going to be plus 4 plus 3? Okay, see, I've been doing this for a lot of years, plus 4 minus 3, and being able to do that simple trinomial factoring mental math in your head, and just go from this step to this, is a very, very useful skill you guys need to practice and get good at. Okay? How about what's the GCF for the denominator here? Yeah, see the x squared? And what are going to be the binomials? Yeah, negative 3, negative 5. Remember, that's the shape of the structure. That's a negative, that's a plus. So we're going to say x minus 3 and x minus 5. Now, what is division, boys and girls? Do you remember? Multiplying by the reciprocal. So we're going to say multiply, and let's factor the denominator first and put it on top. So what's the GCF of this denominator? X. And what are the binomials? Let's see, plus 7 minus 5. You guys see plus 7 minus 5? X plus 7 and x minus 5. Okay. And what's the GCF up here? X cubed. What are the binomials? We got, I think it's 8 and 4. What kind of 8 and what kind of 4? It's minus 8 plus 4. Okay, now we're not done. Now we got to look at this big thing and see what kind of things can cancel out. Oh, there's lots of ways to do this. Let's do the binomials first. I see a plus 4. What else? Minus 5. What else? Got the minus 3s and the x's. Do I have 2 x's there on top and 2 x's here on the bottom? So I can cancel those with that. You're left with that, that, and that. So this equals x plus 7 over x cubed times x minus 8. Are we done with the problem, though? No. When you're multiplying and dividing rational expressions, you have to put in restrictions on the variable. What variables for this denominator would divide by 0? Wouldn't it be 3 and 5? You see that from those, and 0. You see that from those three factors right there? So with this answer, we have to say x cannot equal 0, 3, 5. What about this denominator? How about 8 and negative 4? And remember, we had a denominator here at the beginning of the problem. So we have to handle this denominator too. It looks like negative 7, and we already had the 5. So that's going to be the entire answer that they're looking for to multiply or divide rational expressions.